Alright. Oops, helps if I get a microphone on. Alright, so today we're going to start talking about 9.3. 9.3 is sequences. Alright, so first of all, a sequence is just a progression of numbers. So we're going to talk about that. They're numbers in a list. I keep going. Alright, all of these sequences can be defined two different ways. We can define them explicitly or regressively. Okay? Those two words should sound familiar to you. We had to do those a little bit back in Algebra 1. The word explicit and the word regression. Hopefully it sounds vaguely familiar. Okay. Well, let's kind of touch on it a little bit. So here's the thing. Explicit, I think it's better if we do it this way. Explicit, you use or you plug in the number term to evaluate. For recursive means it's recurring over and over and over and over and over. So to evaluate this one, you use the previous term. Previous term. Okay? And before we actually get into anything else, we probably should talk about the notation. Because honestly, in this section, it's the notation that's the hardest, even though it's not. But it's the hardest thing to grasp because it looks funny. Okay? So let's talk about the notation as well. In this section, if I have, let's write notation here. If I have a letter with a little tiny letter at the bottom, all this means is that this represents the case term. Alright, I can say the same thing if I have a sub n. That just means that this represents the nth term. If I have a and then sub k minus 1, this means it's the previous term to case term. So it's the one right before that term. It'd be the same if I say a to the n minus 1. Again, that just means it's the previous term to nth term. Alright, so what do you think this means if I were to say a sub n minus 2? What is that? 2 previous, exactly. 2 previous. Alright, so that's what that notation means. Okay, so using that, here is example number 1 that I want to get into. Example number 1, and this is really all we're doing at the very beginning, from 1 to 4. It's going to say, find the first. I think they asked for 6 terms. And the 100th term. And then maybe they give you a formula. Let's say a sub n equals n minus 2 over n. So to find our first term, we plug 1 in for n. So if I plug 1 in for n, I get 1 minus 2 over 1. Negative 1, right? That's my first term. To find my second term, I plug 2 in. 2 minus 2 over 1. 0. Oh, sorry, over 2. My bad. Still 0. My bad. Alright. Now I'm going to plug in 3. 3 minus 2 over 3. What's this one? 1/3. How about 4 minus 2 over 4? 1/2. How about 5 minus 2 over 5? 3/6. Say 1, 2, 3, 4, 5. We need one more. 6 minus 2 over 6. 4 over 6, which is 2/3. Alright, you guys check my math? 2/3? Okay. Alright, so that's the first part of this question. Then I want to know the hundredths term. Well, how did I figure that out? Plug in 100. So we have 100 minus 2 over 100. So 98 over 100, which reduces to 49 over 50. Alright, so that's all you're doing for the first couple. They give you the formula like I did up there, and you're just plugging in 1 through 6 and 100, and that's it. Okay? Alright, let's look at example number 2 then. Example number 2. On example number 2, this is actually going to cover 5 through 10. Get the right page here. Alright, so this is 5 through 10. In this one, it's similar. They're going to ask you to find the first 4 terms and the 8th term. But this time, the formula is written regressively. Okay, so it's a little bit different. So let's say I have a sub 1 equals 6, a sub n equals a sub n minus 1 plus 5. Let's talk about this notation. A sub 1 means it's the first term. So my first term is 6. Alright. Now, this says if I want my second term, I put 2 in for n. That means I have 2 minus 1. I take my first term plus 5. So I get 11. If I want the third term, I take the previous term and add 5. So I have 16. And this notation says I take the previous term, which is 16, and I add 5. Everybody okay with that? Here's the problem with recursive, though. There's no way to just jump to the 8th term. Right. That's why they don't go too far, and that's why we don't like to use recursive, because it's always using the previous information. So you can't just jump to 8 because you don't have the previous information. So we've got to keep going. That's 4. Our 5th term then would be 26. Our 6th term would be 31. Our 7th term would be 36. So then our 8th term would be 41. Does anybody want to see another one like this at all? You guys are okay? Ben's like, no! Alright. So let's go on then. I have some new words I want to talk about. There are 2 of them. There's the word converge. Maybe converge, if I can spell it right. There we go. Converge and diverge. Huh? Come together, yes. So when we talk about converge, when it comes to a sequence, it means that if the limit, so the number you're going to, is a finite number. It's an actual number you're getting to. Okay? Diverge means that as you're going through the sequence, you're not getting closer to any number. Maybe its limit is infinity or non-existent. Okay? So just real quick, I'm going to go back to that previous problem we did. Let's talk about this one. As those numbers go out, you're out to 100, right? The 100th number, we get 49 over 50. What number are we getting closer and closer to as the sequence keeps going? You're getting closer and closer to 1, right? It's never going to get over 1 because the top's always going to be smaller than the bottom. But it's getting closer and closer to 1. So is this converging or diverging? It's converging, right? Because it's getting closer and closer to a number. Whereas for a divergent one, let's say I have a sequence that looks like this. 3, 6, 12, 24, 48, and so on. Where's that going to? It's going to infinity. It's not getting closer to anything. So that would be a divergent one. Alright? So here is example number 3. This would be from numbers 11 through 20. And I know you're just doing odd, but I like to do it in the whole section. Alright? I want to know, does it converge or diverge? And if it to what number? Sorry about that. Alright, so let's try this. What if I said I had 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6? Is that getting closer and closer to something? 1 over 7, 1 over 8, so eventually it'd be 1 over 1,000, 1 over 1,000,000, 1 over infinity. What are we getting closer and closer to? It's getting smaller and smaller and smaller. Can it ever equal 0? It's getting closer to 0 though, isn't it? So that would be our limit. So this converges, and it equals 0. Okay? Another example? Yes? Yeah. Okay. What about, let me give you this one. What if I just said 3n minus 1? So now we got to decide what they are, right? I'm going to plug in for the first one. I plug in 1. I get 3 times 1 minus 1. So I get 2. For the second one, I get 6 minus 1, which would be 5. And for the third one, I get 9 minus 1, which would be 8. Fourth one, I get 11, and so on. What does this one do? Yeah, it diverges, right? Because it's not going to anything. It's going to infinity. Okay? Alright, next part. I want to talk about 2 different types of sequences we can have. I'm almost done. Oh, 2 different types. We have, when we talk about the types of sequences, we have arithmetic. Make sure I spell that right. That's an E in there. Sequence. Which means that I'm adding the same number each time. When we say that we're adding the same number, that number is referred to as D, or the difference between the terms. Okay? The second type we're going to have is called geometric. You probably guessed, in this one we are multiplying by the same. Multiplying by the same each time. Now, because I know you guys, I'm going to give you the formula for each. Because that's what you guys like to work with. Most of you like to work with. Okay? So, for an arithmetic one, my formula, in order to find anything in there, is going to be a sub n equals a sub 1 plus, in parentheses, n minus 1 times d. For the geometric one, we're going to say a sub n equals a sub 1 times r to the n minus 1. Alright, so let's look at both of these. Okay, so here is example number 4. 4? Okay, example number 4. Yeah, absolutely. You there? Okay. For example number 4, this one is going to cover 21 through 24. And I'm going to tell you, let's say you have the sequence 6, 10, 14, 18, and so on. I want you to find, Oh, okay. I want you to find several things for me out of here. First question is going to ask you on, here it's going to say for part A, what's the common difference? 4, I agree. And this one, it equals 4. For part B, it's going to say, what is the 10th term? Alright, so we've got to write our formula. So we're going to start with a sub n equals our first term, that's what a sub 1 means, which is 6, plus n minus 1 times by d, and you guys told me the difference was 4. I'm looking for the 10th term, so I'm going to put 10 in for n. Alright, so I have 6 plus 9 times 4, or 6 plus 36? 42. Part C, I want you to write a recursive rule. So we're going to talk about writing the recursive rule. When we write the recursive rule, you start, and there's 2 parts to it. The first one is always a sub 1 equals whatever your starting number is. In this case, your starting number is 6. Okay? The second one starts with a sub n equals. And you literally put a sub n minus 1 plus your difference. In this case, 4. That's it. That's the rule. Okay? Part B is going to ask you to write the explicit one. Well, guess what? This is the explicit one. Okay? You guys want another one? Another one of those? I still have 5 minutes. Chill it out. You're fine. Let me do one more then. Example number 5. Example 5. I want to do one with geometric real quick. Okay? Which will cover 25 through 28. And then the 29 and 31 are actually applying the stuff you already talked about. You'll be fine. Alright, in this one, if I give you, let's say, 3, 6, 12, 24. Alright, this time we're multiplying by something and counting, right? So part A, what is our ratio? What are we multiplying by each time? 2. Awesome. Part B, I want to know what the 8th term is. Alright, so let's talk about that formula I gave you, which is technically the explicit formula. We have a sub n equals the first number, which is 3, times the rate, or the ratio, which is 2, to the n minus 1. So I'm going to find the 8th one. I'm putting 8 in for n. I want to know 3 times 2 to the 7th. You get that for me, Carly?
384.
Thank you. Then part C wants you to write it as, I'll put it over here, recursive. Alright, so here's recursive again. First one is a sub 1 equals, the starting number is 3. The bottom one is a sub n equals a sub n minus 1 times by your ratio. In this case, 2. That's it. And of course, this is the explicit.
Do we have to rewrite it?
Nope. As long as I see it there somewhere, I'm good. Yeah. Yeah, absolutely. Is that far enough? You're very welcome. Ah, come here. So you're doing 1 through 31 odd. It's really not that many problems. Some of them should be quick and easy. Should be. Oh, I forgot to stop.